stochastic gradient descent. Okay, so stochastic gradient descent, in short we call it SGD. Okay, and you have a regressor as well as a classifier for this.
Okay.
Okay, this is similar to your elastic net, or in this case, what happens? Okay, stochastic gradient descent. Okay, as its name suggests, gradient descent. It finds the best, regression line. Okay, it also does same thing. Okay, it actually. Okay, so yes, can see my screen, right?
Yes, sir.
Okay, so let's say you have. Okay, we'll talk about regression first. Okay, so let's say you have this regression line. Okay, and you have values here. It will move, okay, it will have two things. Okay, one is the movement on this, isn't it? Should, how far it should be from origin. And second movement is the angle itself, slope itself.
Yeah.
Okay, so again, it tries to move around. Okay, and the concept is it finds the error. Okay, and whenever the error, okay, so I just said, right, first maybe we'll start from somewhere here. Okay, and then slowly it is going to come down. So you initially dots are, let's say here, error will be, if you get error will be maximum. Okay, and then it will start and it will go, right? That means somewhere here there is a perfect value for slope and the constant C. Okay, so it will move faster, okay, initially, and then, okay, so let's say error is 30, it became 25, and again it became 30. That means the actual value is between this 30 and 30. So if we're decreasing at rate of 10, now it will start decreasing at 5 or 1. Okay, so finally wherever it is able to find minimum value, that is your, okay, that is your error. Okay, and it takes your tolerance limit. Okay, tolerance limit means at what what is the minimum distance you want to go for. For example, in this case, first I started with gap of 10, then I said 1. So tolerance limit is 1. If I give tolerance limit minus 0.1, it will go up to minus 1. Okay, so it tells you how much, okay, how much, what should be the value at which you are checking. Okay, so again, let's take this example one day. So let's say at y value 60, okay, you get 30, and y value 50 you got 25, and y value 40 you got 30 error again. That means the between 60 and 40 is the actual accuracy, right?
Yeah.
So first you had 1 to 100, and you're going from 100, 90, 80, 70, so on. Now you will go at 1 by 1, 60, 59, okay, 58, 57, so on. So let's say at 50 it is 25, at say 51, it came 26, okay, error, and 50 it came as 25, and then again at 50, 49,
26,
okay,
or 27.
26, yeah, let's say 26 or 27, yes. So that means now the answer is between 51 and 49.
Yeah.
Now third iteration you will do 0.01. Okay, that
Yeah.
means 50.09, 50.9, 50.8, 50.7, so on. Again, you'll find the range where it's going to minimum and again increasing. Okay, so this will go on till our the value that we are giving. Okay,
Yes, sir.
so let's try to do the classifier here. Okay, so in this case, okay, we will call linear model only. Okay, so from that is also a linear model. sklearn dot linear model import. Okay, stochastic SGDs, stochastic gradient descent. Okay, SGD. Okay, classifier. Okay, and then here the classifier will be, okay, classifier equal to SGD classifier dot fit, isn't it? Okay, no, first fit is there. Sorry, you have to first call the object. Okay, so in the object, okay, we give here what is the maximum iteration that you want to perform. Okay, so if you do not find the answer, okay, it will stop after max iteration. Let's say I give max iteration as 5,000. So 5,000 comparisons it will make. Okay, if it finds the answer before 5,000, then it will stop. But if it does not find answer, like still it knows that, oh, I can still find minimum value, that's when you stop.
So even though we give the number, if it finds below that limit only, it will stop it.
Yes, or maximum that limit.
Okay. Yeah.
I'll tell
Yes,
you in the exam, right? We give timeline, correct? 3 hours exam.
Yeah.
If you are able to solve before 3 hours, you will give the paper and walk out.
Yeah. Yes, sir.
Okay? So if you are able to find the answer, if algorithm finds the answer before 3 hours, it will find, give the paper and walk out. Otherwise, you'll keep on solving till it is time. 3 hours done, give the paper and walk out.
Yeah.
So we don't want machine to go on forever. That's
Yes,
the reason.
yes.
Okay, it's if not able to find the, so it'll say, okay, let me calculate more and more. So that's the thing, that you do not want machine to work forever. And then you have TOI, tolerance limit. Okay, and I'll define tolerance limit as 0.01 or something. Okay, 0.01, 0.001. Okay, more value you give, more accurate your result is going to be.
Yeah.
Okay, but at the same time, you should not be overfitting also.
Yes.
Okay, and then another factor is called penalty. Penalty is like which algorithm, which model it should begin. See, the STD is the procedure. Okay, check this. But which algorithm should you run? Okay, so I'm going to say elastic net or linear model. Okay, so I'm going to say okay. Now see the same thing. In Google, go and click scikit-learn.org. Okay, and give the thing. It will take you to the official documentation site. If you want to know, then you go to the official documentation site and then find out this. Okay, elastic net, and that is it, I think. Okay, so here the accuracy is low compared to others, isn't it? Okay. Okay. Now, next one, I told you boosting algorithm, right? When you're working with weaker algorithm, we prefer boosting algorithm. One is ensemble. Ensemble is where you run multiple algorithms and you take average. That's what random forest does. Ensemble.
Yes, sir.
You say 10, so it will run. It will create 10 decision trees by taking different starting value, and then you take the average of the 10, so you get decision tree. Okay. In ADA boost, that we're going to talk about is called ADA boost. In ADA boost, okay, the output from one model goes as input to another model.
You said this, yes, sir.
Yes, boosting, correct. Okay, goes as input to another model. Again, the output from second model go as input to, again the
Third
example,
model.
right? Yeah,
Yeah.
the assignment first person does is that sense. It also tell you that I am sure about this, but I'm not sure of others,
Yeah,
right?
yeah.
So that fellow has the knowledge that, okay, you know, you have solved it. Okay, maybe that person may not spend much time on whatever solution we got. Definitely
Yeah.
you will check if the answer is correct or not. It's not that you blindly accept it. You will check, but the importance that you'll give or the time that you'll spend on that will be less. So how does it happen is, I'm going to take one example, okay? And how, you know, we can use tree technique for boosting. So let's say I take a Excel. Okay. Now there's a, okay, better, can I open my notes one second? Okay. So let's say, okay, we have, okay, 3 input values: chest pain, blocked arteries, and patient weight, okay, in pounds. Based on these values, we are trying to predict if that person is going to get heart disease or not.
Okay.
Okay.
Yes.
So let me put that. Chest pain, blocked arteries, and weight. Okay. And why is your
Heart disease.
heart disease? Okay. So here we have yes, no, yes, no, yes, yes, no, no, yes.
Yes and yes.
Okay. Here we have yes, yes, no,
Yes,
yes,
yes.
yes,
Yes. No, yes.
no, yes. 205, 180, 210, 167, 156, 125, 168, 172. Okay.
Yes, sir.
And then here it says first 4 cases, yes. Okay. Okay. So this is the training data. Now we need to learn and create a decision tree from this. Okay. So I told you, right, I will see how Gini index works. So, you know, that concept will do. Same concept is repeated multiple times. Okay. First, I'll tell you how decision tree works. Okay. Okay. So begin with, okay, so these are called weak algorithm, right? Does not have much of, it's not as strong as SVM. Okay, so it's important that we do some kind of boosting, whether you do ensemble like random forest or you do boosting like ADA boosting. Okay.
Sir,
So
1 second.
mhm.
Then we know it is weaker.
Decision tree is weak. Okay, decision tree means what? It is just making decisions, right? Now, if you look at the groups, right? If you try to visualize.
No, what I'm saying is,
Huh.
when we already know it is weaker, so what is the point in using this algorithm to fit any data?
That's why we are doing stronger. No.
Okay.
Okay. Weak
Okay.
doesn't mean it's of no use. Right?
Okay.
We
Okay.
know it is a weak, so we are forming a team. We will do random forest. We will do ADA boosting.
Okay.
Okay. And sometimes if the algorithm, the data set is for where see weak also means that you can work with it faster. The result will be faster,
Okay.
isn't it?
Yeah. Yeah.
Okay.
But the accuracy, we have to compromise on that.
How do you know without running the model?
I mean, you're saying it.
Sometimes see
Yeah.
weak doesn't see sometimes making a lime juice will be more better than making a apple juice, right? People might like your lime juice better than apple juice.
Okay.
Which takes more effort, apple juice or lime juice?
Apple juice.
Apple juice. But if
Yes.
sometimes if they can like your lime juice more than your apple juice, possible or not?
Yeah. Yeah. Yeah.
So what I'm
Possible, sir.
saying is depends upon what is the data type.
Okay. Okay.
It doesn't
Okay.
mean that if you make lime juice, it's not good. You have to put a lot of effort. Only it is good.
Okay. Got it, sir.
Okay.
Yes, sir.
Great.
Understood.
Okay. So to begin, okay, first we have to give a weight because this is a first step. Okay. We don't know which one. Chatting also I'm doing with my team. 1 second.
Yes.
Okay. So I was saying that, okay, initially, okay, we don't know. It's like giving you 10 questions or 8 questions, right? And you are the first person to solve. When you are the first person to solve, okay, when you are the first person to solve, you you don't know, right, which answer you will know, right? When you pass on to the other person, then only you can say, oh, this question number I have done it well. Okay.
Yeah.
So initially we'll start with weight as 1 by total this thing. So it is 1 by total is 8. So we'll start with 1 by 8 initially. Okay. Okay. Now we have to create a stump. What is stump? Stump is a tree with just two values. Okay, this is the one, right? Okay, so this is called stump. Okay, stump means decision tree with just two values, yes, no. Okay, there is no second level. Okay,
Yeah.
and so for chest pain, yes, disease. Now let's say if you have to predict only based on chest pain, if you have to predict only based on blocked artery, if you have to predict only based on weight, then what does it mean? Okay, so if I have to predict only based on chest pain, let's say, and I am saying if you have yes chest pain, you will have disease. Okay, if you do not have chest pain, you will not get this heart disease. This is my initial assumptions.
Okay.
Okay, so how many correct and incorrect? So if I believe that if you have chest pain, you will get a disease.
Yes. Yeah.
Okay, so just look at chest pain and disease.
1, 2.
First, look at yes, yes only.
3, sir.
1, 2, 3.
Yeah.
Right? So
3.
correct is 3.
Yeah.
How many is incorrect? That means
1.
chest pain, yes, but heart disease, no. Chest pain, yes. 2, right?
Yes, 2. Yes, sir.
2. Right? Now, no, no. So look at our NN. So here we have NN, right? So 2 NN,
2.
right? And how many incorrect? So incorrect means
1.
no chest pain, but still you have heart disease. So somewhere
1.
here.
1, sir.
1, right?
Yeah.
Yes, 1. Okay. This is called stump. Okay. Now, similarly, let's make one stump for blocked artery also.
Okay.
Okay. And then we'll make one for weight also. In weight, we will say weight greater than some value, right? So pick some middle value. So we have 172, right? You can pick maybe 170.
150 or something.
150 will be lower side. You can take 170
168.
to, yeah, 168 or and it did not be among this value, right?
Understood, sir. Yeah,
Okay.
between, yes.
Yes.
Yeah,
So,
160 or 170. Yeah.
yeah, so 170, 200 is there now. So pick something in between. Okay.
200, above 200 only 2 are there.
205. See, minimum is 125, maximum is 205. So 125 plus 205 by 2. So 330.
360, 180.
180, right? So somewhere around 180 or 175 you can take.
Okay.
Okay. So
Yes.
if weight is more than 175, yes, okay, we have to redo stuff, right? Okay. Okay. Now, chest pain, yes, yes. So these are yes, right? So look at all yes.
2.
So no, this is blocked artery.
3. 3.
Okay. So these are all 4 yes, right? So 3, correct?
Yes.
So 3 and incorrect is 1, correct? No, no, incorrect, we don't know. Incorrect means yes, blocked artery. Okay.
3,
and
sir.
no. So
Yeah,
if you
3.
take this 3. Okay. Now let's say in this case, let's say if we had got 2 and 3 down, okay, then better we will switch the condition. Okay. Yes, no, and no, yes type. Okay. Okay. Now here, blocked artery, no, no. No, no means 1, right? And if you look at blocked artery, no, no, but still you have it.
1.
Okay. Okay. No, but still you have it 1. Okay. Now you tell me here. Weight more than 175. Okay. So very difficult, right? Let's make it something like this. More than 175, we will highlight. Okay. I think this is good. Okay. So now if you see weight, okay.
All are correct. 3.
Oh, 3 out of 3.
Yeah.
Okay. Incorrect. Incorrect means more, but no heart disease. 0.
0. Yeah.
Okay. Now here, less than 175.
5. 4. 4 correct.
Okay. 4 correct. And 1 wrong.
Yeah.
Okay.
Yes, yeah.
So this is the first step. Okay. After creating stump, find these values. Okay. Now we have to find Gini index. Okay. Gini index is your total, okay, correct by your total error. Okay.
Yes, sir.
Okay.
Yes, sir.
Okay. So Gini index. Okay. So formula I'm trying to recorrect. Okay. Okay. So formula is here. 1 minus, okay, pi square. Pi square means your probability square, probability of true. Okay, is subtracting the sum of squared probability of each class. Okay, probability of each class. Okay, now if you see correct, how many correct we got? 5. 5 by 8. So probability of getting correct here is 5 by 8. Okay, so you do the square of this 5 by 8 square, and then probability of getting wrong, it is 3 by 8 square. 1 minus pi whole square. Okay, so if you come here, okay, we'll calculate pi here. Pi first. Pi here is, we'll say pi correct and pi wrong, probability wrong. Okay, so here you got 5 by 8 and this is 3 by 8. That means 1 minus if you do, you will get it, right? And here it is what? 4 by 8. Okay, 4 by 8. And here
7 by 8, 1 by 8.
right?
Yes, sir.
So it is 7 by 8 and it is 1 by 8.
Yeah.
Then what do? We do the square,
Yes, sir.
right? We do square. So let's say we put square here. And then 1 minus square of pi. Square, okay, square. Okay, so it is like this.
Sir, does pi stand for pi?
Pi stands for what?
No, probability.
Probability.
Oh,
I is just indexing. Not pi pi. It's just a suffix.
Okay,
okay.
so it is I have to find square first, isn't it? Square. Now we need to find the sum.
Yeah.
Now we have to find 1 minus. This is a Gini index. This is how we end up calculating Gini index. Okay. So Gini index is 0.47, 0.5, and 0.22.
2. Yeah, 2.
Okay.
Yes, sir.
Now we have to, okay,
Blocked artery gene index is high.
right. Now, okay, we have to, okay, this is here, right? High Gini index means, you know, your calculation is, you have got it more wrong, basically.
More wrong.
Correct.
Yes, sir. 1 minus, no? Yes, sir. Yes, yes, yes.
Right.
Yeah.
But you're doing both here. You're doing both.
Yes, sir.
correct or wrong. Okay. Okay. So the next step, so you have found Gini index. Okay. Now, whatever has the lowest Gini index, okay, that would be the first value that we are going to select.
Okay.
Okay. And then we have to add the weight also of the stump. Okay. So let's see the formula here. I'm going to build this table. Okay. So we calculated. Yes. So Gini index for patient weight is the lowest, so it will be the first stump in the forest. Next step is to calculate the weight of the stump. Okay, what is the weight? Total error for a stump is the sum of the weights associated with incorrectly classified sample. Okay, because when you are passing right, you will pass saying that these are the incorrect ones.
Yeah.
So see, we are still in the first step. Okay, we'll calculate first step and then pass on to the next step.
Yes.
In this case, it made only one incorrect classification. Okay, so total error is 1 by 8. Total error is 1 by 8. So when stump has lower error value, the amount of save will be relative large positive value, right? Opposite of that.
Yes.
If total error is 0.5, then the amount of save will be 0. Okay, 0.5 means what? You got half right, half wrong.
Yeah.
Right? So when the total error is 1 by 8, the amount of say is 0.97. Okay.
How, sir?
Okay. So here you see 1 minus total error by total error, and that is half of log. Okay. See, I'll tell you here you have. So this is amount of say e to the power 0.097. Okay.
Yeah.
So sample weight is going to be your new sample weight. The next iteration going to be current sample weight, which is 1 by 8 into e to the power of amount of say. E to the power of amount of say is this.
Okay.
Okay. So if you do, if it is 0.5, 1 minus 0.5 is 0.5.
0.5. Yeah.
0.5 by 0.5 is
1.
1. Log of 1 is 0.
0. Yeah.
Yes. That's why you
Yeah.
get 0.
Long back.
Yes. Now, if you go here, okay, if you find 0.22 is what we are taking, isn't it?
Yes, sir.
Because that is the lowest, okay, Gini index. So this is what we need to take. Okay.
Yes, sir.
Now, here, if I do log of log base 10, right? Or natural log 2. Okay. So we would do natural log.
Okay.
Natural log of 1 is 0. So
Yeah.
now if you say here, it will be what? 1 minus 0.22 divided by 0.22. Okay.
Yes, sir.
Is it 1 minus log of 1 minus 22
Correct.
divided
Sir.
by, okay,
Yeah.
and then if you divide, no, okay, I think it's log 10.
And half of this, sir.
Okay. 1 minus,
Point.
we will take this,
Yeah.
divided by this. Okay. Okay. And then you take half of this.
Yeah.
Half of this will be even less, no? Okay. So we'll stop here. Okay, we'll continue tomorrow.